Hello, everybody. I hope you all are having a good night or day, whatever it is for you. So, I wanted to bring up a couple of interesting topics in terms of dealing with black holes, the term universe, and space time. So, follow along with me real quick. The Big Bang and the nova of a star resulting in a black hole are essentially the same thing. You have at a fraction in time the collapse of a massive amounts of matter which all pull inward because of gravity and simultaneously an expansion because of the density of the energy being pulled together. So I'm going to show you what I mean real quick with this photo. So um, if you pay attention, you have at but a fraction of time uh, the pull inward, which would be gravity, and then you have the density, which would be the inflation, and then the creation of an object, right? Or a black hole. Well, in our case, we call it Big Bang, which would have resulted in our universe, right? So I'm going to keep reading real quick. Um, this then forms a sphere of matter that cannot escape or be pulled inward any closer, right? We call it singularity, so to speak. A vacuum of what would appear to be empty space, but actually full of condensed matter, almost like an ocean of plasma. And so this would be the cosmic radiation or the cosmic background when what you would see with sensors that can pick up radiation, because to us the observable universe is just you see darkness if you look up into space, but there's actually radiation everywhere. If you go beyond our sun's solar system, there's actually plasma all around us, and even outside that visible plasma that we can see because of the energy that it's moving at, there's actually all types of radiation everywhere, even in the darkness of space. So now I actually understand the idea of dark matter. It's essentially matter and energy that we cannot see at the wavelength because it's not in the color spectrum for us. A vacuum, a vacuum of what would appear to be empty space. Shout out Carl Jones. Um, a vacuum of what would appear to be empty space, but actually full of condensed matter, almost like an ocean of plasma. I like to argue the same thing happening inside of a black hole is what happens in our observable universe. So we say it's the vacuum of space, and that's comparable to the vacuum in a black hole. If you were to actually go into outer space or into our solar system without a spacesuit on, all of the oxygen and different elements would escape rapidly because because of the I would say because of the electromagnetic properties in different molecules like oxygen, it will be pulled towards a different source. That's actually how lightning works. You have different charges between the sky and in the ground, and so what happens is at a split second, you're seeing a massive amount of energy being released or moved from one particle to the next when it is moving. Um, I like to argue the same thing is happening inside of a black hole in our observable universe, a vacuum of radiation and cosmic energy we cannot see because of the wavelengths they travel and are outside of our visible color spectrum. What appears to be black is a sea of particles and fluctuations in space because of the charges and gravity, and actually density, because um, that's another subject though. Relativity could argue that this is all instant to another observer, like how we see in a black hole when a star novas and it explodes and then a black hole forms. One could argue that this is all instant to the outside observer, but to us on the inside, it would appear to be slow in nature um, because of our experience and how we experience the universe. Um, Relativity could argue that this is all an instant to another observer, but because of the speed we experience and or perceive the universe, it would be slow in nature to us. This would cause a fractal paradox in terms of observable universes and would mean that there are infinite universes, black holes inside of black holes. To us, our universe being reality, while to an outside observer seeing nothing but a black sphere in their space-time, and to another being a fraction of our size, having an observable universe, but to us just another black hole in our sky. And so when I use this fractal as an example, not only does it look like a galaxy actually, what I mean is, so if you go into space, or if you look in space, there are black holes, right? And so within those black holes, one could argue that's an observable universe on the inside, and what we see is the sphere on the outside, the 3D object. Well, one could argue that all of our space that we see completely is a black hole, but we see it as an observable universe. So I wanted to show you a couple of these pictures. This is what how we see black everywhere in space. This is what the universe actually looks like under sensors that can pick up radiation. It will be all types of different colors like this. And so if you watch a video of a star nova and then turn into a black hole, throughout time, it basically will be the same thing as this. And to us, it may seem instant, but to the people inside, it will be a long time, because time is relative to the perceiver. And so even outside of that, I wanted to show you all something real quick. This is what's considered a quark-C, or these are gluons, and they rest inside of a quark-C, like this. If you pay attention to a quark-C and the gluons, it is the same colors and the same idea as the cosmic radiation. Now, the reason I say that, I bring all that up to say this. When you look at colors, think of colors as energy. You're only seeing it as a color because that's how your eye perceives the energy in the brain. So we see a color spectrum, but in ideology, those are actually just energy waves or particles moving at that energy length. And when the eyes pick it up, that's how the brain perceives the data. So if you pay it, and this is the inside of an atom, how they used to say it's just a proton, an electron, and a nucleus or a neutron. Now, if you go even deeper into those particles, the protons and the neutrons, you will get a quark-C and quarks. Now, one could argue this is the quark-C, right? And this is our observable universe. I mean, to be honest, when you get lower and lower in ideology, there is no such thing as a particle, because the entire universe is a whole. And I believe that's how time works and why time only moves in one direction. I believe that everything is a whole, and whenever we create a particle or a part of something, what we are actually doing is, within the construct of our minds or the perceiver that is dividing the universe, what they're actually doing is creating sections for a greater whole. So we could say a proton, a neutron, and an electron, but what that could actually be is a part of this universe that we are breaking down by our perception. So, I basically believe I am the universe observing itself. If you pay attention to what stars are actually doing, stars are convectors, or they do convection or something like that, to where they're either recycling energy and then radiating. Our star, what it does is it radiates on the inside and then convects the energy on the outer layers. What supermassive stars do, or stars that move at higher wavelengths, what they do is they convect on the inside, but they radiate on the outside, and that's why they burn so fast and they nova so hardcore, because all the radiation is lost instantly. So basically everything that we perceive to be color is actually just energy. It's a bunch of energy everywhere, and what we perceive to be either clear space or darkness is actually just energy we can't perceive in the mind. It's crazy, right? So nothing is actually empty. And when you think of this entire universe, it's actually a sea of all types of particles and elements that we can't perceive. Even in a vacuum, that vacuum is just a bunch of energy that we can't perceive, and it just seems to be a vacuum. And if you observe the universe under a sensor, this is what you get. So one could argue there are universes within the atoms, right? The gluons. One could argue that there are universes within black holes. You know, the property of this black hole is really equivalent to the property of the universe. So that's why I tell people, you know, if I were a scientist, or if I were somebody that was about, you know, making technology and things like that, I'd make things comfortable. I'd make comfort. You know, it's good to understand everything around you and learn more. I love science, but some of the things we do with technology, you know, especially in dealing with empires and kings and wars. I was watching a documentary called Einstein and the Bomb or something like that, and I never really ventured into that portion of Einstein's life or really was taught about this, but the man had terrible regret. I mean, they used his invention. He even said if he knew Germany wasn't going to come up with the bomb, he wouldn't have did it. He watched his invention kill like 170,000, 200,000 Japanese people, and he was depressed afterwards. I mean, it's crazy the things we do with technology, you know. So I don't know. I just would like to see us go in a better direction towards the future. Maybe create things for positive things. I see a lot of species and creatures that are invasive that people don't want in the environment, but then they mock it and get mad at it. You know, I feel like the world could feed the world and we could just do better things. Some super intelligent genius out there is living on a dock river lake being polluted by capitalists in Nigeria somewhere or India somewhere, but they have no access to anything and are dying. The life expectancy in Nigeria in this riverboat place, they are seeing people from 7 to 27 years old, while people on the other side live in mansions. You know, you guys, with science and technology, we need to start. The only thing I'm honestly going to see defeat kings and religious people is science. And even that science can be corrupted if people aren't ventured in the right direction. So we all need to come together. Maybe religious people and scientists should come together and come up with like a standard or something. And then maybe even outside of that, maybe we should just let each other live and create positive things, because you never know. You know what I mean? We could just be another atomic universe somewhere with atomic universes inside it. Who knows? So I hope that was helpful and understanding. Am I saying we're inside of a black hole? No. Am I saying we're inside of a simulation? Because even as I showed you with John Conway's Game of Life, all energy is just color. And as I'm seeing more and more, it will point towards us possibly either being infinite universes or in some type of digital whatever. So enjoy your life, enjoy what you have, and be thankful.